Okay, so you copied some notes down over the weekend about significant digits, which we also refer to as significant figures. One thing I want you to keep in mind is significant figures apply only to measured quantities, meaning they will have a unit like grams or degrees Celsius or milliliters or joules, things that are measured because these numbers have uncertainty in them. Anytime a person is making a measurement, they are going to be using their judgment on the last digit as they estimate the final digit. So sig figs are defined as numbers that consist of all the digits known with certainty plus one final estimated digit. And that estimated digit is when you're reading between the lines to estimate that very last number. So if your measuring device is marked off to the whole number, you should always read your device to the tenths place. You're estimating reading between the lines. If your measuring device is marked off to the tenths place, you should always estimate it to the hundredths place. If it's marked off to the hundredths place, you should always estimate it to the thousandths place. You must read your measuring device one place further than it's actually marked off, and that's when you're reading between the line. And since it's an estimation, there is uncertainty in that number. Now, the rules for determining sig figs, these are going to be a little bit different than what you're accustomed to when you think of numbers, because normally in your math classes, you're just manipulating numbers and solving for variables and whatnot. But with science, you're going to be measuring, which means you're estimating that last digit. So here are some rules for determining sig figs. And the best way to think about sig figs is instead of questioning the rules, just learn them and apply them. And I promise you, it'll make it so much easier just accepting the rules because they are what they are, and then applying those rules. The first rule says that all non-zero numbers are counted as significant figures. So in this example, 2.47, like if it were 2.47 grams, there's no zeros here. So that means this number, this measurement has 1, 2, 3 significant figures. The second rule applies to numbers that contain zeros. There are 3 types of zeros that you could find in a number. We have leading zeros, we have captive zeros, and we have trailing zeros. There's a different rule for each kind of zero. The rule for leading zeros is they are never counted as sig figs. Even though we see them and we write them, here's a number that has 3 leading zeros in it. Since they are simply placeholders, they're not counted as sig figs. So if I were to ask you how many significant figures were in this particular number, you would tell me it only has 3 sig figs because the leading zeros never count. The 2, the 4, and the 7 are what we call non-zero digits, so they always count. The second type of zero is a captive zero, and captive zeros always count as sig figs. I always think of it as it's like they're trapped in there and you have to count them. So in the number 70,063, we see that we have 2 zeros that are between non-zero digits, which makes them trapped or captive. And they always count. So this number here would have 5 significant figures. You would count every digit that you see here. Finally, you can have zeros that are at the end of your number, and these are called trailing zeros. The rule for trailing zeros is they sometimes count as sig figs. When do they count? Well, when you count a trailing zero is only if you see a decimal in the number, and you must see the decimal. It would not be that it's an understood decimal. So let's look at some examples of numbers that would have trailing zeros and talk about when we would and when we would not count them. In this first example here, we have 1.00 times 10 to the second power. If a number is in scientific notation, you consider just the coefficient 1.00. Notice these are trailing zeros, and we see the decimal here. So that means we will count the zeros. So we count the 1 and the 2 trailing zeros, which means this number has 3 significant figures. In the second example, we have the value 100, 100, and you see the decimal point. So again, trailing zeros with a decimal, you will count them. So this number has 3 significant figures. Finally, if you have the number 100 with no decimal point, if you don't see the decimal, you do not count the trailing zeros. So you would tell me this number, since there's not a decimal, you would only count the 1, so there's 1 significant figure. The final rule for sig figs is when you have specific instances where you have unlimited sig figs or infinite sig figs. This occurs when you have counting numbers, which are exact numbers. Like if we were to, for example, have exactly 21 students in our classroom, we would have had to count it out, that number of students. And so when you count something, physically count it, there's not any uncertainty. So there's no estimated digit. It's a definite number. So you would tell me that had unlimited sig figs. Students is not a unit of measure. Students are people or things. Likewise, if I were to say I had 12 donuts, I would count the 12 donuts. Donuts is not a unit of measure. But if I said I have 12 inches, then that would be a measurement because it has a unit. Finally, the other instance when you have unlimited sig figs is when you have a defined quantity, which are also known as conversion factors. For example, 60 minutes is equal to 1 hour. That is not a measurement, that is a definition. 60 minutes is always equal to 1 hour. Or 100 centimeters are in 1 meter. That is a definition. 12 inches equals 1 foot. That is a definition. There's no uncertainty. Therefore, we say that they have unlimited significant figures. So let's do some practice. In your notes, you have 8 examples. So take a minute with your partner and try to determine how many sig figs there are, and then if there's zeros, what kind of zeros there are. Please pause this for just a moment, and then once you're done, start it again and check your answers. Okay, so in this example here, there are no zeros. I see a unit of measure, so I know it is a measurement. So I count all 3 numbers. This number has 3 significant figures. In number 2, we have a leading zero, and the rule for leading zeros is they never count. So this number also has 3 significant figures. In number 3, I see 2 places that there are zeros. So since they're captive, both of these are considered captive zeros. You're going to count them, which means you count every digit that is present. 1, 2, 3, 4, 5 significant figures. Here we have a number that has been written in scientific notation, but remember, you look at the coefficient. And we also have zeros. These zeros are at the end of the number, so we call them trailing zeros. So we look for a decimal. Since I see a decimal here, I'm going to count the trailing zeros. 1, 2, 3, 4, 5 significant figures. And number 5, we have trailing zeros again, and a decimal, which means we count the zeros. 1, 2, 3, 4, 5 significant figures. Now in number 6, this one might be a little tricky, but you have to pay attention to the unit. Meter sticks is not a unit of measure. Meter sticks are objects you would have to count out. So if I were to tell you I had 22 meter sticks, that means I would have counted them. It's the counting number. So therefore, it has unlimited sig figs. Number 7 has a unit of measure, meters. I have leading zeros, which never count. I have a captive zero that always counts, and I have a trailing zero, so I got to look for my decimal here. I look back and I see a decimal. So I do not count the leading zeros. I count the 7, the captive zero, the 8, and the trailing zero because of the decimal. So I have 1,